Let's try another problem. So it's the reaction of hydrogen and iodine monochloride. You have the experimental rate law. Suggest a plausible mechanism for the reaction. So this time we don't have additional hints. Is it a two-step mechanism? Is it a fast reversible step followed by the slow step? But since we have an idea, most of the reaction mechanisms that we encountered, they are usually a fast reversible step followed by a slow step. So what if we try using that pattern? So this is my proposed mechanism. So I have H2 colliding with ICl. So this is reversible and it forms HCl plus HI. And then my second step will be HI colliding with ICl, forming I2 and another molecule of HCl. So let's try to add the two steps and we get the overall reaction. That's 2HCl plus I2. So our intermediate in this proposed mechanism is HI. Okay. Now, in order to remove any biases or something, let's just stick with this, that the first step is a reversible step, but the second step is a single-headed. So it's not reversible. So single-headed arrow siya. We will not be preempted by the idea that the first step is fast and the second step is slow. So tanggalin natin yon. So let's be content first. Na first step is reversible and then the second step is not reversible. So we don't know which is the slow and which is the fast step. Hence, we use the steady state approximation. Okay? So for the steady state approximation, for this one, as a steady state approximation class, because it revolves or it centers on your intermediate, you will choose the step with an intermediate as your basis. And that is your second step. Gets? That's another hint, class. If you are going to use the steady state approximation, so 'di ba, wala tayong idea kung alin yung slow, alin yung fast. So ang basis nyo, class, take the rate law for the step na merong intermediate. Okay? So for this one, we will take the rate law for second step as our basis. So this will be our basis. Again, we will try to eliminate this HI. Kasi intermediate siya, and what we learned about reaction mechanisms, yung rate loss nila dapat walang concentration term for an intermediate. So we will eliminate this. And this is where the steady state approximation comes in. So again, the steady state approximation tells us that the rate of formation of your intermediate, so rate of formation of HI, is equal to the rate of consumption. So kaya siya tinawag na steady state kasi after several seconds when your reaction starts, the reaction or the concentration of your intermediate remains constant. Yun yung steady state na tinatawag. Kasi there comes a point in time na kung gaano man karami yung na-form na intermediate, ganon din karami yung nagagamit na intermediate. Okay? So for example, nagkaroon ka na ng 10 molecules ng intermediate. Yung rate of formation niya is 2 molecules per second and yung rate of consumption niya is also 2 molecules per second. So you form 2 molecules but you will also use 2 molecules. So na-maintain yung count na 10 molecules at any point in time. That's your steady state. So here, we will look at the reactions that form HI. And don't forget that we include the backward reaction of a reversible reaction. Okay? So, Rate of formation of HI. So anong steps yung nagpo-form ng HI? So it's the forward reaction of the first step. So that would be, so i-assign ko lang yung mga rate constants natin. And this is K2. So that would be K1 times H2 times ICL. And then that's the only step that produces HI. Now, what are the steps that consume HI? Number 1, yung backward ng first step. So that would be K negative 1 times HI times HCl. And then the second step also consumes HI. So that would be K2 times HI times ICl. And now, we isolate HI. So HI is equal to K1 times H2 times ICl over K sub negative 1 times HCl plus K2 times ICl. Okay? So we substitute this for HI here. So we have K2 times this whole expression, K1 times H2 times ICl over K negative 1 times HCl plus K2 times ICl. Excuse me. Times ICL. Times ICL. Saan galing yung ICL na yan? Ito yon. Okay. So now we make the assumptions. Okay. First assumption. Our first assumption will be K negative 1. So yung assumptions, di ba ginagawa natin para may ma-eliminate tayo sa denominator. First assumption, K1 is much, much greater than K2. What does that mean? Your first step is faster than your second step. So kahit na yan yung backward, kasi nga reversible yan, di ba? So kung mataas yung backward, it also follows mataas din yung forward niya, yung rate constant para sa forward. Okay, so if this is the case, so first step one is a fast step. What can we do with the denominator? Okay, so kung sobrang liit ng K2, it means this term is negligible. Or we say that K1 times HCl plus K2 times ICl is just approximately equal to K1 times HCl. Okay, so this is eliminated. And then, so what do we have? Anong magiging itsura ng ating rate law? So we have rate sub 2 equals K2 times K1 over K negative 1 times H2 times ICl squared over HCl. So di niya kamukha. Ito yung experimental eh. But we have another assumption. We can make another assumption, right? What is the second assumption that we can make? So instead of step 1 being your fast step, what if yung second step yung fast? Ayun. Therefore, step 1 yung slow. So that assumption will be like this. So you have K2 much, much greater than K negative 1. So, step 2 is a fast step. So, in this case, yung nasa denominator natin, we can eliminate the first term. Right? So, this is approximately equal to K2 times ICl. So, ito yung ma-eliminate instead of the second term. So how will our rate law look like? So that's rate 2 equals K2 times K1. So we have H2 times ICL squared over K2 times ICL. And simplifying that, we have K2 canceled out, ICL also cancels out. And essentially, what do we have? We have the rate law for the first step, K1 times H2 times ICL. And this one is the same as your experimental rate law. So apparently, kahit hindi na pala tayo nag-steady state approximation and we just went ahead just by observing that the rate law for first step is the same as the experimental rate law. So kahit hindi na kayo nagganito, hindi na kayo nag-derive, sabihin nyo agad, the rate law for the first step looks like the experimental rate law or is equal with the experimental rate law. Hence, we say that the first step is the slow step followed by the fast step. Yun na. So this is an acceptable reaction mechanism. Okay?